Hello and welcome to my workbench under the stairs. And today I've got a vintage laptop with a very common vintage computer problem. A, its BIOS battery is dead. So what? But it's not as simple as just popping in a new 2032. Like most other vintage laptops, this Dell Latitude C-610 takes a proprietary battery pack that is not easily obtainable. Okay, so now to start the repair, the first thing we've got to do is dig into the laptop and find its BIOS battery. Now, despite this nice trap door, you won't find it under here. Trap door. You'll have your RAM, your Wi-Fi card, but no BIOS battery. So instead, we have to open, it's actually mounted under the keyboard. So we have to undo every screw marked with a K. Well, at least Dell was nice enough to mark that. So to open this up, I'll just use a little something I picked up at my local big box store is a power precision screwdriver. So I'll just start by taking out the screws, again marked with a K. Now this is a little slow, but it seems to have good torque. Now I'll just remember to put it in. Okay, and turn the laptop over. Open it up, and now we should be able to take a flat blade screwdriver and lifting up and out of the way. And what we have is an attempt at a bodge job, a bodge repair. So at first I'm going to just check this bodged in BIOS battery, and so I'm going to hit negative on negative and on positive. We've got, well, 0.6 volts, which confirms that even this bodged in mess pretty confirms that this in fact is dead. 4 button cells is probably 6 volts, which given on the Dell service manual for this laptop shows a 7.2 volt battery, so even that might even be insufficient. Now, one other thing I do want to check is the laptop trying to charge a nickel cadmium battery? So again, taking my voltmeter onto negative and the positive. The laptop is plugged in but showing no voltage, but we'll try with the system running. I've just turned on the laptop. It's running. And no voltage coming through, so it doesn't try to charge. So I'm just going to take out this mess right here. I'll just power up my soldering iron. So now we have to fix one janky hack repair with another janky hack repair, but hopefully this time with some better batteries. I bought some good lithium button cell batteries, 3 volts each, so I'm going to use 9, even though it's only a 7.2 volt original. Just putting a diode in series will drop that extra volt, so this time this should work well. So I should be able to just solder them together, one stacked on top of the other, and to give me 9 volts, which I can just drop with a diode. So to start with, we'll first need to just sand a little bit of the surface of both the front and back of each of the batteries, just to kind of clean them up and shine them a bit. And now the first thing I'm going to need to do is to attach a little bead of solder to each battery front and back. And I'll just mark up a little bead of solder. I'm going to try to avoid heating the battery too much, because they say it shouldn't be bad to solder directly onto these batteries, but I can't see it being any much good either. Oh, it's sticking. I need more on the edge. And you can definitely tell there's a really big thermal mass on these batteries because the solder is hardly sticking. So, got a little warm there. It seems to be sticking more on this side. Okay, you know. So I'm gonna try to attach the front of one battery to the back of the other to try and solder them together. Now this is the bead on my good Radio Shack solder. And this is the no-name stuff that I got with my soldering station. So quality counts, people. So when you use your clamps to solder these button cell batteries together, you have to make sure you insulate between, because the metal clamp, because the front's is positive, back is negative, it's going to be a direct short circuit. So you will need to have something like a plastic or paper or something as some insulation. So I'll just put that like that and just put that into. Now I got to make sure I align together carefully, and now I got to see, can I now join the solder I put together on these, can I join that together? And I am just not really getting a lot in there unless I just try some more solder. Now it looks like it's starting to melt together in there. Okay. Okay, I'm right-handed. I'm trying to solder left-handed. Okay, here we go. And I think it's bonded already. And now we give it another voltage test. Okay, so now that I have all three batteries soldered together, I'm going to do one more voltage test. And what we got? 8.6, that looks good. So the next thing I'm going to need to do is I'm going to need to attach some wire leads to attach my batteries to the motherboard. So I'm just going to take a red and a black wire, probably no more than a few centimeters, and attach it to the solder pads on the motherboard of the laptop. Okay, so I'm just going to go about the length of my thumb, which should be roughly about 4 centimeters or so. And just very carefully strip off between roughly 5 millimeters. And then going around and around when you feel that there's no more, when you feel nothing but resistance from the wire, you just pull, twist, and you're stripped. The wire, that is. What were you thinking of? Okay, so next thing I'm going to tin the leads of the wires that I just stripped just to make it easier to solder onto the battery pack. And this is where this cheap no-name solder is actually not too bad. It's just little short jobs like this, but anything that's got like a big heat plane, yeah, that's kind of where it's a little bit useless. So now I'm ready to solder the wires onto the batteries. So I'm going to start with the positive, and I'm just going to grab my soldering iron, and then I've got a blob of solder I put on the positive already, and I'll just hold down. I should just the solder that and now now the positive's in place, and now we just do the negative. There we go. Now we got it. Albeit a little janky, but I guess that's to be expected. Okay, so I'm going to attach the new battery pack into the laptop, remembering negative back, positive in front. Now I'm going to do the final installation of the new BIOS battery pack into the laptop. I'm taped it up to ensure there's no short circuiting anything else on the motherboard. So I'm just going to kind of fit it nice and snug, and then just pop the keyboard back in. So after having the power plug disconnected for a couple of minutes, hold on. After having the power plug disconnected for a couple of minutes, I'm just going to check to see if there was if it drained out the BIOS settings. It might for one last time, but we'll try resetting, but it should keep them. So now we've got loading screen. It's not saying anything about so I think it's not complaining about a dead BIOS battery yet, or a reset CMOS yet. So oh yeah, now it just did. So now we just hit F2 to rerun our BIOS setup, and now we want to hit, come on, what the, oh, my down key doesn't work. Oh, okay, says change fields down. I got dead keys. Oh good. While fixing the BIOS battery, I have started encountering a problem with the keyboard. The the keys on the left-hand side of the keyboard are working, but the right ones are not. So I am hoping that the problem is just the ribbon cable connecting the keyboard to the motherboard. One side just popped out of the socket on the motherboard. And I'm hoping that that ribbon cable hasn't broken, as it is over 20 years old now, and ribbon cables like that can be quite fragile. But looking from this angle, it could very potentially be that that's all we're looking at is just half the cables popped out of the socket. So what I'll do, I'll disconnect it, reconnect it, and see if the whole keyboard begins working again. So after unplugging and replugging the keyboard um, ribbon cable back into the motherboard, I'm going to power up the system and see if I have full keyboard control again. Okay, it's entering setup, and no. Okay, my up arrow key works, but yet nothing else does. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, I can Alt P to the next page. Okay, so it's just my back and forth keys. I don't have any function on those. So up, down, no. So I'll go, let's just see if it will let me enter. You see my down key doesn't even work either. So I don't know if it's just the keyboard or if it's something else. So, well, I found the cause of why my keyboard died, and it's my fault with my soldering iron. I should have taken it out. Should have fully removed the keyboard before soldering the new battery in. So may that be a reminder. Watch what you're doing. To test, no, to test if my replacement CMOS battery was successful, I did manage to set some settings like the time and date into the BIOS setup with the remaining keys that do function, and it's been disconnected from power for the last several hours. So we'll plug in the power and I'll try starting the system, and we'll see what comes up. Now, now it looks like it's now it looks like it's just progressing through post quite normally. It's not giving me any messages of corrupted BIOS. So I think we might. What? So after leaving the power disconnected for a few hours, the computer has reverted back to its 2003 date, which means it's not holding its BIOS settings. So unfortunately, instead of a fix, we have a fail. I made a mistake when I incorrectly diagnosed the BIOS as being unsavable. And man, this really makes me feel like a dolt. Now, I took my clue from the previous hack repair job and just soldered the wire to the big solder pads here and here. But those were just the pads that the old plug for the BIOS battery that the plug-in for the old BIOS battery was held onto the board with. But the actual electrical connection was here and here. This one being negative, this one being positive. And I can show that with my ohm meter. And I can show this with my ohm meter. I've already got the ground plane of the computer connected to my negative lead of my multimeter. I'm set on ohms. And the first thing I'm going to do is I'm going to go right into is where the negative is soldered on, and I've got a dead open. I move to this other little um, solder pad here, and I show 0.3 ohms, full continuity. So that tells me that these two solder pads are going to be the correct ones to attach my battery to. But now the thing I need to reestablish, now that I know which solder pins are attached to the BIOS, I still need to find out, is there charging voltage on the BIOS battery? So I'm now set to ohms, now set to volts. I now have to, and now even with the system powered off, I've got 19 volts coming through on the positive lead that should be going to the BIOS battery. So that means is going to be charging, this is going to be charging a rechargeable battery, which is something we do not want. So now going to system running, still shows about 18.5 volts. So it means I will need the diode after all. Okay, so the first thing I'm going to have to do is desolder the battery from the incorrect solder pads. And for this, I'm going to be using my needle tip for my soldering iron. And why don't I have mine? There we go. And needle nose pliers. And next we go. Just move it back. Now, normally, I'm normally not a fan of these kind of needle tip, because you can hardly get any 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 of the thermal mass, and you can't get the solder to melt with it. So I've heard it's really just good for some surface mount applications, normally but for normal, like through hole soldering or point to points, needle tips are generally kind of useless. There we go. Of course, just when I thought it was off, there we go. Okay, so now that I know that I'm going to be installing the diode to protect my non-rechargeable batteries from the battery circuit in the laptop, I've already put my battery pack. I've already put my battery pack, and I've already installed a diode coming from the positive. So I'll just check with my voltmeter, and I get my
And I've already installed
8.5
a diode
volts.
coming from the positive,
And then just to check,
so I'll just check with
I'm
my
just going to
voltmeter,
wire it
and I get my eight
backwards,
and a half
and I should
volts.
get
And then just to
next to
check,
0.
I'm just going to wire it
So
backwards,
installed this
and I
way
should
from the
get it
positive, it'll let
next to
um,
0.
the voltage flow from the batteries into the BIOS chip, but then it will block the charging voltage from the laptop from reaching the battery pack. Okay, so returning back to my chisel tip, I'm just going to take the positive lead off the battery. Now this is where you got so much thermal mass in these batteries that my soldering iron just can't keep up. So I'm always melt some solder on here, and there we go. So now we take my diode and take its tiny little lead and then just heat it up. The solder. There you go, and now it's on. So now we'll take this and we'll just properly put a nice little J hook on the connector. And now make a good mechanical connection. There we go, and a little dab of solder, and so now we're ready to put it back in the laptop. So first things first, I'm just going to do a little cleanup in the laptop. Just get rid of excess solder, just so that we're not going to short anything out. And that's looking a lot better. So now here's where I could use a little extra help here. Right. So next I'm going to go okay. Am I running? Yes. Okay, so I'm going to start with the negative lead. I'm just going to grab a needle or a little pair of forceps to help precisely hold my wire down to where I need to solder it. So next, There we go. Okay, so negative's on. And now, gotta do the very fine with the positive lead. Okay, now very finely line it up, and hopefully I've got enough solder on both the connection and so, now I'm going to some power to the system again, and just to make sure. So, do we fly or do we fry? Now, and now that I'm plugged in, now we check for voltage. So on the outside of the diode, of course helps to put it on voltage, not resistance. So voltage outside the diode, 19.3 volts. Now we get this, and then on the inside of the diode, again not showing anything, but is it protecting? We'll see.
So the laptop has been disconnected from power overnight, so I'm just going to plug it in, power it on, and see if it held the settings. And there we go, a very fast post. And it's not complaining, so I think, and it's booting, so it did held the settings, so that part's fixed.
So now that I've got the BIOS battery sorted out, I now move on to the keyboard that I damaged the ribbon cable with my soldering iron. Now this part I'm hoping should be an easy fix, but there is some good news and some bad news. When I looked at some up close photographs, I realized that there's only two conductors that were broken. So that's not too bad, but the one thing I think is not going to be so good is the fact that it was damaged so easily with my soldering iron. So I'll have to be careful. I'm going to set my soldering iron to around 250 degrees Celsius. The first thing I'm going to have to do is remove the outer coating of the ribbon cable with my Dremel. So despite my plans for a quick repair for the keyboard, unfortunately, it's not to be. I initially planned on scraping away the outer coating of the ribbon cable with my Dremel and then just soldering in a couple wires to fix the broken conductors. But unfortunately, I tried the first side, I tried the clear side. After about 30 seconds, it just did not even look like I scratched it. So I turned it around, tried the black side, and I broke it even worse. Those the the black side of the ribbon cable, it stripped off just fine, but took the metal conductors with it. These are very, very, very thin, so I think even soldering would not have fixed it. So I'll just show you a quick magnetized picture to show you the damage done. So without a quick fix for the keyboard at this time, so the takeaway from the BIOS battery is what needs to be known to make a replacement for a proprietary CMOS battery for a vintage laptop is number one, what is the required voltage for the battery? If you can't find this on the battery itself, it'll be on the service manual for the laptop. Second thing you got to know is the laptop built to charge a rechargeable battery? If it is, you'll just need to put a diode in to stop the charging the power from reaching the battery and destroying it. And thirdly, space constraints in the laptop case are, and what replacement batteries can be made to fit. So I'm being unable to fix the keyboard, but getting the BIOS battery working, I'll take that as a quick win. So I'll see you again next time, right here on the workbench under the stairs. So when I turn on the laptop after leaving it unplugged for a couple of days, this is what I get. No more BIOS settings saved. So why did my repair fail? Well, I'll grab my meter and let's find out.
Okay, so I'm just checking the voltage here. And with my negative lead on the ground of the laptop, checking the positive, I'm showing nothing. And even on the lowest scale, it's not coming up with anything. So the laptop drew enough current from the batteries to kill them. So let's just check it on ohms to see how much resistance we have inside from the BIOS battery to ground to see how much current is going to be pulled. Okay. And starting on the 20 kilo ohm scale, showing open, and 20 on 200K shows open, and on 20 meg shows open. So I don't know what gives, but I will be back on another video to take another shot at it. So until then, more to come later.